Hey guys, welcome back. Now let's get started with our day 19 walkthrough. You guys can go ahead and read the story here. So coming to the learning objectives, understand what memory forensics is and how to use it in digital forensics investigation. Understand what volatile data and memory dumps are. Learn about volatility and how it can be used to analyze a memory dump. Learn about volatility profiles. What is memory forensics? Memory forensics, also known as volatile memory analysis or random access memory forensics, is a branch of digital forensics. It involves the examination and analysis of a computer's volatile memory to uncover digital evidence and artifacts related to computer security incidents, cybercrimes, and other forensic investigations. This differs from hard disk forensics, where all files on the disk can be recovered and then studied. Memory forensics focus on the programs that were running when the memory dump was created. This type of data is volatile because it will be deleted when the computer is turned off. What is volatile data? In computer forensics, volatile data refers to the information that is temporarily stored in a computer's memory and can be easily lost or altered when the computer is powered off or restarted. Volatile data is crucial for digital investigators because it provides a snapshot of the computer's state at the time of an incident. An incident responder should be aware of what volatile data is. The reason is that when looking into a device that has been compromised, an initial reaction might be to turn off the device to contain the threat. Some examples of volatile data are running processes, network connections, and RAM contents. Volatile data is not written to a disk and is consistently changing in memory. The issue here is that any malware will be running in the memory, meaning that any network connections and running processes that spawned from the malware will be lost. Powering down the machine means valuable evidence will be destroyed. What is a memory dump? A memory dump is a snapshot of the memory that has been captured to perform memory analysis. It will contain data relating to running processes captured when the memory dump was created. Benefits of memory forensics. Memory forensics offers valuable benefits in digital investigations by capturing real-time data from a computer's volatile memory. It provides rapid insight into ongoing activities, detects stealthy threats, captures volatile data like passwords, and allow investigators to understand user actions and system states during incidents, all without altering the target system. In other words, memory forensics help confirm malicious actors' activities by analyzing the computer system's volatile memory to uncover evidence of unauthorized or malicious actions. It provides crucial insights into the attacker's tactics, techniques, and potential indicators of compromise. Another thing to keep in mind is that capturing a hard disk image of a device can be time consuming. Then, you have to consider the problem of transferring the image, which could be hundreds of gigabytes in size. And that's before you even consider how long the analysis will take the incident response team. This is where the memory analysis can really help the IR team. Capturing a memory dump from any device will be much faster and smaller. Suppose we prioritize RAM over a hard disk image. In that case, the IR team can already start analyzing the memory dump for the IOCs while beginning the process of capturing an image of the hard drive. What are processes? A process is an independent, self-contained unit of execution within an operating system that consists of its own program code, data, memory space, and system resources. Imagine your computer as a busy chef in a kitchen. The chef can cook multiple dishes simultaneously, but to keep things organized, they use separate cooking stations for different tasks. Each cooking station has its own ingredients, pots, and pans. These cooking stations represent what we call processes in a computer. This is crucial in memory forensics because knowing the processes that were running during the capture of the memory dump will tell us what programs were also running at that time. We can categorize processes into two distinct groups. The user processes are those where the user directly interacts, whereas the background process is where the user does not directly interact. Volatility. Volatility is a command line tool that lets digital forensics and incident response team analyze a memory dump in order to perform a memory analysis. Volatility is written in Python and it can analyze snapshots taken from Linux, Mac OS, and Windows. Volatility has a wide range of use cases, including the following: listing any active and closed network connections, listing a device's running process at the time of capture, listing possible command line history values, extracting possible malicious process for further analysis, and the list keeps on going. For this task, we'll examine the memory dump of a Linux device. For your convenience, volatility is already installed on the VM. We can look for different help options using this command. Volatility profiles. Profiles are crucial for correctly interpreting the memory dump from a target system. A profile in volatility defines the operating system's architecture, version, and various memories specific to the target system. Using the appropriate profile is crucial because different operating systems and versions have different memory layouts and data structures. Volatility comes with many profiles for the Windows operating system, and we can verify this using this command. Profiles for the Linux operating system have to be manually created from the same device that the memory dump is from. Here are some of the reasons why we typically have to create our own Linux profile. Linux is not a single monolithic operating system, but rather a diverse ecosystem with many distributions and configurations. Each distribution may have different kernel versions, configurations, and memory layouts. This variability makes it challenging to create one-size-fits-all profile for Linux. Unlike Windows, which has a more standardized memory structures and system APIs, Linux kernel internals can vary significantly across different distributions and versions. This lack of standardization makes it difficult to create generic Linux profiles. Linux is open source, meaning its source code is readily available for inspection and modification. This leads to a greater flexibility and customization, but also results in more variability in memory structures. Creating profiles is out of scope for this room, so for your convenience, a profile has already been created. To use the profile, we have to copy it where the volatility stores various profiles for Linux. So once we are done with this, we have to run this command to confirm that our profile is set. So now let's go ahead and fire up a machine. Memory analysis. The file linux.mem contains the memory dump of the Linux server we are going to analyze. The file is located in our home directory. For volatility to begin the analysis, we have to specify the file with the -f flag and the profile with the -- profile flag. We can use the -h flag to look at all the different plugins that we can use. Volatility plugins. History file. The history file is a good place to start because it allows us to see whether there are any commands that are executed by a malicious actor while they were on the system. To examine the history file for any such commands, we can use the linux_bash plugin. The command will take less than a minute to finish executing. So now let's open the terminal. So now let's copy this command. Now let's copy this to confirm that our profile is set. Now let's copy this. So now let's copy this. Okay, so the first question here is, what is the expose password that we find from the bash history output? So this is the history output. Let's wait. Okay, so here we have the password. Let's copy this. When performing a cross-reference check with the ELF analyst who was using the server, we identify the following suspicious commands. The MySQL command was used by the ELF analyst, but the cat command was not. This means that the malicious actor most likely saw the MySQL command and had access to the database. There is a lot of sensitive information about the merger and the pipelines that the malicious actor could have gained access to. We also identify the curl command, which the ELF analyst confirms they didn't use themselves. This tells us that the malicious actor used the curl to download the toy miner file and saved it using the -o parameter as a file name miner. We can also see that the malicious actor executed the miner file using the /miner command. Now that we understand what the malicious actor executed, we can look into the system's running processes. Now let's copy this command. As you can see, this plugin doesn't just list each process name. It also lists the process ID and the parent process ID. This helps determine what is often referred to as parent-child relationship between processes. There are only two anomalies that we quickly identify. The ELF analyst confirmed they didn't execute the miner process. Based on the program name, our initial assumption is that we may be dealing with a crypto miner. A crypto miner, short for cryptocurrency miner, is a computer program or hardware device used to mine cryptocurrencies. Cryptocurrencies are digital or virtual currencies that use cryptographic techniques to secure and verify transactions on a decentralized network called a blockchain. Our insider threat could be trying to use our Linux server to mine cryptocurrencies and make some extra ELF bucks. The MySQL server appears to be benign, but this is misleading. The process for MySQL is called MySQLD as listed above. The ELF analyst confirmed that they didn't execute this. Given that the PID of this process is different from the PPID of the miner process, this process did not spawn from the miner directly. We would like to know more about the processes. A good way to do this is by examining the binary of each process. We can do this via process extraction. So now let's make a directory. Now let's copy this command. So here we have a miner and the process ID is 10280. So let's go to the second question. What is the process ID of the miner process that we find? Now let's substitute this with our PID. So now let's list the contents of the extracted directory. So now let's copy this command. So here let's change our process ID. Okay, so now we got a hash. Let's copy this. So coming to the third question, what is the MD5 hash of the miner process? So let's paste this. So if you notice here, the previous command we used here was for the miner and the one we are using right now is for MySQL server. Let's paste this now. So now let's copy this. So now we have the hash. Let's copy this. So the next question here is, what is the MD5 hash of the MySQL server process? Use this command and find out what is the suspicious URL. And let's replace the PID with our process ID. So here in the question, it also says fully defang the URL using CyberChef. So let's open CyberChef in a new tab. So now let's search for defang. So now let's go and find the URL. Okay, so here we have it. Let's copy this. So now let's paste it here. So here we have the output. Let's copy this. As stated above, we want to look at any cron files that may have been placed by the malicious actor or the crypto miner. This could help us identify if there is any persistence mechanisms at play. For example, is the MySQL server process we found before part of the persistent mechanism? But how can we enumerate the files on the server? We can utilize this plugin to help us with this. The benefit of this plugin is to help us review any files of interest. The plugin's output will be too large, so we can use the grep utility to help us focus on our search. So now let's copy this. We quickly identify the cron tab is located in this location. We speak to the ELF analyst who confirms that they didn't have any cron job set up on the server. We can now extract the file using the inode value and using the -o option to name a file during the output. Now let's copy this command. So coming to the last question, after reading the ELFI file, what location is the MySQL server process dropped in on the file system? So here we have the location. Let's copy this. So now we have successfully completed our day 19 walkthrough. Thank you for watching my video and stay tuned for more.